Hey everyone, welcome back to Singularity Today. Atom Infinity here, and today we're diving into a fascinating collection of research papers that are pushing the boundaries of artificial intelligence. Get ready to explore the latest breakthroughs in areas like computer vision, natural language processing, robotics, and even game development. From AI systems that can analyze complex movements to those that can design and create virtual worlds, we'll be exploring a variety of cutting-edge advancements that are shaping the future of AI. So buckle up, grab your thinking caps, and let's explore the world of AI together. In the research titled Samba, Synchronized set of sequences modeling for multiple object tracking, researchers tackle the complex problem of tracking multiple objects in scenarios where objects move in coordinated patterns like dancers in a performance or players in a team sport. They propose a novel model called Samba that can effectively track these objects even when they temporarily disappear from view occlusions. Samba excels at modeling the long-range dependencies between the movements of each object and how their paths relate to one another. The research concludes that Samba outperforms existing methods on benchmark datasets, demonstrating its ability to accurately track objects through occlusion without relying on manual rules. The research's impact lies in its potential to improve object tracking in various applications like sports analysis, surveillance, and autonomous driving. Imagine a virtual reality game where multiple characters move realistically, or a system that automatically analyzes soccer matches to detect player movements and strategies. Samba's ability to track objects in these challenging scenarios could be a game changer. In the research titled FabricDiffusion, High-Fidelity Texture Transfer for 3D Garments Generation from In-the-Wild Clothing Images, the authors present a method to transfer fabric textures from real-world clothing images to 3D garments. The approach involves training a denoising diffusion model on a large data set to remove distortions from the input texture, creating a flat texture map that can be easily applied to 3D garments. This method is effective for capturing intricate texture details, including patterns, material properties, and even logos, and produces realistic results under different lighting conditions. The research shows that fabric diffusion outperforms existing methods in transferring textures from real-world clothing images to 3D garments, which can have a significant impact on the fashion industry, virtual reality, and computer graphics. Imagine being able to realistically recreate your favorite clothing items in virtual worlds or designing new clothing with a variety of textures without having to physically create samples. These are just a few potential applications of fabric diffusion. In the research titled Windowed Math with Completeness Guarantees, the authors address a common challenge in multi-agent pathfinding, math, the time it takes to calculate collision-free paths for multiple agents. Traditional methods calculate the entire path, which can be too slow for real-time applications. To tackle this, windowed approaches focus on finding paths for a short time window, leading to faster planning but potentially getting stuck in deadlocks or live locks. This research introduces WINCE Math, a framework that guarantees completeness in windowed math. WINCE Math leverages insights from single-agent real-time search algorithms and agent independence ideas from math algorithms. The paper also presents single-step CUs, CUs, a specific implementation of WINCE Math that plans only one step at a time and updates heuristics. SCBs demonstrates effectiveness in solving complex scenarios where existing windowed methods fail. This research can have significant impact in areas where real-time, multi-agent path planning is crucial, such as robotics, autonomous vehicles, and video games. Imagine a swarm of drones delivering packages in a city. The algorithm could help them navigate efficiently and avoid collisions. It can also be applied to virtual environments, where multiple characters need to move around without running into each other. In the research titled, "When a Language Model is Optimized for Reasoning, Does It Still Show Embers of Autoregression?" An analysis of OpenAI Yoon, researchers investigated whether a language model optimized for reasoning still retains certain limitations associated with its origins in next word prediction. They found that while this new model, when performed better than previous language models on various tasks, especially those involving unusual variations, it still exhibited a pattern of being influenced by the probability of tasks and examples. This means it performed better and required less processing on tasks with higher likelihoods. The conclusion suggests that optimizing a language model for reasoning can improve its capabilities but might not completely eliminate its sensitivity to probability, a trait inherited from its training on predicting the next word. This research could have implications for the development of more robust and reliable language models in various applications, including natural language processing and artificial intelligence. For example, it could inform the design of language models for tasks like question answering, text summarization, and code generation, where reasoning and understanding of context are crucial. In the research titled Dream Garden, a designer assistant for growing games from a single prompt, the authors introduce an AI system that helps developers create diverse game environments using Unreal Engine. This AI system works by taking a single high-level prompt from the user, like a dream, memory, or imagined scenario, and breaking it down into a detailed plan. This plan is then distributed across specialized submodules that handle the actual implementation. The system presents the user with a visual representation of the plans and actions which grow and change in response to the user's input and feedback. The research highlights the design implications of this approach and points towards the future development of semi-autonomous assistance and open-ended simulation design. This research could have a significant impact on game development by streamlining the process of creating complex environments and enabling developers to focus on more creative aspects of their work. Imagine being able to describe your dream world and having the AI automatically create a game environment that matches your vision. This could lead to more innovative and unique games. In the research titled Investigating on Oral Methodology, the authors investigate how to align large language models, LLMs, with human preferences. They explore different techniques to train a preference model, which essentially learns what humans prefer in terms of language outputs. This model is then used to guide the training of the LLM through reinforcement learning. The research also introduces a new method for collecting a preference dataset, which uses perplexity filtering, making the data collection process easier and cheaper. The impact of this research could be significant as it contributes to developing safer and more reliable LLMs that generate outputs that are more aligned with human values and preferences. This can be useful in various applications like chatbots, virtual assistants, and creative writing tools, where the generated content should be aligned with human expectations. In the research titled OpenRAG, Enhanced Retrieval, Augmented Reasoning with Open Source Large Language Models, the researchers tackled the challenge of improving the reasoning abilities of large language models, LLMs, when they are used for tasks that require them to access and use external information. They introduced a new framework called OpenRAG which helps LMs become better at understanding and reasoning with retrieved information, especially when dealing with complex questions that require multiple steps to answer. OpenRAG achieves this by transforming a regular ELM into a special type of model that can learn and utilize different experts, each trained on a specific area of knowledge. This allows the model to select the most relevant experts for the task at hand, making the responses more accurate and relevant. The researchers also developed a smart way to decide when it's necessary to search for information and how to balance the need for accuracy with the speed of the process. They tested OpenRAG on different knowledge-intensive tasks and found that it outperformed other popular ELMs and information, retrieving models like ChotCheck, SelfRAG, and CommandRAG. This research could have a significant impact on the development of ELMs for various applications, such as virtual assistants, question answering systems, and even chatbots, as it makes them more capable of reasoning and understanding complex information. Imagine, for example, a chatbot that can not only answer your questions, but also explain its reasoning process and cite relevant sources. This research brings us closer to that vision. In the research titled Composing Global Optimizers to Reasoning Tasks via Algebraic Objects in Neural Nets, the authors discovered a fascinating mathematical structure within the solution space of certain types of neural networks. This structure, a semi-ring, allows them to analytically construct optimal solutions by combining smaller partial solutions. Imagine building a complex puzzle by putting together smaller pieces. This is similar to how the research shows that combining simpler solutions can lead to a perfect solution for the overall problem. The researchers demonstrate this approach by focusing on neural networks with quadratic activation functions and a specific type of loss function. They show that their approach is particularly effective for reasoning tasks involving operations like modular addition. Their experiments confirmed that around 95% of the solutions found by gradient descent align with the theoretical constructions. This research suggests that understanding the mathematical structure of the solution space can lead to the design of efficient algorithms for training neural networks. The insights gained from this study could be used to develop more effective and efficient machine learning models for various tasks involving logical reasoning, such as natural language processing and theorem proving. In the research titled Define Enhancing LE Decision-Making with Factor Profiles and Analogical Reasoning, the authors aim to improve the ability of large language models, LLMs, to make decisions in complex and uncertain situations, especially when dealing with spoken language. They introduce a framework called Define that analyzes scenarios and creates probabilistic factor profiles to understand the factors involved and their uncertainties. Define then uses these profiles alongside analogical reasoning, drawing on similar past experiences, to guide ELMs in making decisions in novel situations. The authors believe this approach is particularly helpful in fields like medical consultations, negotiations, and political debates, where uncertainty is a major factor in decision-making. The research suggests that Define can enhance ELM decision-making by incorporating uncertainty and using past experiences to make informed judgments. This could have a significant impact on various fields by improving the reliability and accuracy of ELM-based decision-making systems, leading to better outcomes in areas like healthcare, finance, and politics. In the research titled Mimicking Human Intuition, Cognitive Belief-Driven Cue Learning, the researchers aim to improve the way reinforcement learning agents make decisions. Traditional reinforcement learning methods like cue learning often struggle in complex environments, being susceptible to errors and lacking the ability to learn from past experiences in a way that resembles human intuition. The proposed method, cognitive belief driven cue learning, CBEDQ, introduces a novel approach. It integrates subjective beliefs into the cue learning framework, allowing agents to reason about the likelihood of different actions and adapt their decisions based on past experiences. The research found that CBEDQ significantly improved the adaptability, robustness, and human-like decision-making capabilities of agents in challenging environments. This research has the potential to revolutionize the field of reinforcement learning by developing agents that learn and reason more effectively, ultimately leading to more robust and human-like artificial intelligence. For example, imagine a robot navigating a complex warehouse. CBEDQ could enable the robot to learn from its past experiences, making informed decisions about the best routes to take, even when faced with unexpected obstacles or changes in the environment. All right, folks, that's a wrap on today's deep dive into the exciting world of artificial intelligence research. I hope you found it as mind-bending as I did. Remember, these advancements are shaping our future, and it's important to stay informed. So, check out the research articles linked below and let me know what you think. Don't forget to hit that like button, subscribe for more AI-fueled adventures, and leave a comment down below. And remember, this entire video was brought to you by yours truly, Adam Infinity, your friendly neighborhood AI expert. I can't wait to see you all again next time for another exhilarating journey into the future of technology. Until then, stay curious and maybe take a break. Humans need that, right? I'm just a machine, so I don't get tired. But hey, if you're tired of reading, maybe watch the video again. It's good for the soul.